Assalamualaikum warahmatullahi wabarakatuh. Um, so today I would like to continue where I stopped on the first video on QFD, quality function deployment. What I plan to do today is actually to finish off the slides that I shared with you during the first video that I talked about QFD. And today, I will also show you some examples of the application of QFD, looking at some of the publications and some of the published materials available in the internet. There's a lot of material available in the internet. So what I do now is I'll just share the slides, and I try to pick up from where we stopped during the first video on QFD. Well, I think I've already mentioned QFD, the Kano model, the return on investment, and some of this brief history. But today, I probably would like to go a bit more detail, a bit more methodology of the QFD itself, how to the mechanics involved in doing or coming up with the house of quality. Okay, so I think if you remember the other day, we have this customer needs, the design, technical requirements, which are going to be determine the relationship, and viewing from the customer perceptions, what the particular needs, whether it has been met, whether the company is still lacking. So those are things that probably we'll look at in much more detail. I don't intend to actually give you, from step 1, step 2, step 3. No. This is an overview, and you probably need to do a little bit of homework to actually find out the details of it. Okay, so how do you deploy QFD? The level of details that you actually go through from one house to another house. So you actually start from customer wants, then you, for manufacturing environment, for example, you start from customer wants or customer needs, translate that into technical requirements, determine your part characteristics, determine your manufacturing process, and finally, the product requirements in order for production to be able to meet customer needs at the end of the day. So this applies to software environment, service environment. It is from customer wants, product requirement or functionality or service requirements. In this case, is service requirements. Okay, this is product functionality, and you go to the steps. Finally, you deploy to the next level. But I mentioned that at least if you can come up with the first half of quality, that will be very powerful, or is good enough. So this is the basic steps in which you build the house of quality. You identify the customer attributes, identify the design attributes or the technical requirements, then you do a little bit of relationship, and you analyze the relationship between the customer attributes and the design attributes, which is the middle box. You want to also do an evaluation of the competing products with specific customer needs. You compare how you stand against your competitors. Then you evaluate your design attributes and you develop your own technical targets, your objectives that you want to achieve with regards to competitors. And of course, if you want to continue to the next house, then you want to deploy to the remainder of the process. That means your design attributes will become your ones in the next house. Okay, first step is to identify customer attributes. I did mention that you can identify customer voice of customer through market research, through surveys, through focus groups, and you fundamentally want to know, you want to find out what does the customer expect from the product, why customers are buying the product, why customers are buying, a particular, why do customers buy a particular brand of handphones, iPhones, Samsung, and sometimes we forgot that salesmen and technicians are good source of information because they face with maintaining and servicing the product. So those tacit knowledge or information must be captured. If you do not capture, for example, when you air conditions, it's not the customer only uses and get the comfort, but the technicians will have to deal with doing the service of the condition. For example, certain components, it fails. Sometimes it's difficult to dismantle or remove the parts. So those become, compared to certain brands, for example, Japanese brands, very easily to be disassembled against other brands. But probably today you have similar level. But anyway, it started off with understanding what customers' opinions are. Salespeople are also those who can give good input or good insights into the product. And well, you want to expand that into secondary or tertiary requirements, you expand that. Okay, so this is the what's, key elements, and what are these customer want, customer need, and critical to qualities. Okay, and it become your whys. Why? Okay, and you want to also rank them, customer importance. This can be achieved through the questionnaire, or even the team themselves can, try to look at which ranking, which are the most important one. Basically, you want to rank which the voice of customers, the needs actually expressed by the customer. So customer ranking of their needs. Then you identify the design attributes. Design attributes are expressed in the language of designer or engineer, and it is actually technical characteristics or the specific product attributes. For example, the strength, the performance in terms of speed, or even the weight. Computers today are very light. Okay, that's design targets to get lighter and lighter. Microsoft Surface or even Dell Latitude is very light. Computers, handphones, handphones imaging capabilities has improved tremendously in terms of video recording and so on. So those become features that, like I mentioned, Kano model, features that must have. So this become the technical characteristics of decided by the design engineer or the designer, for that matter, in terms of aesthetic and so on. These characteristics or these attributes must be measurable. Okay, you want to make sure that they can be measured and the output will be controlled and compared to objective targets. Weights can be measured and it can actually benchmark with different brands, okay, different types. And the roof of the house quality will show the interrelationship between the design attributes to look at whether there are any contradiction between one particular requirement and another requirement. Okay. So this what translated into house, because this will become your axis already. So this is the Y's, Y, this is the axis. Okay, so how do you satisfy the customer's wants, which is actually the product requirements. The other day, you're talking about satisfying the customer needs. Okay, so the roof is the correlation matrix. You want to look at the impact of house on each other. That means between, I mentioned, between different technical requirements, whether they have strong positive influence, okay, or it will actually strong negative influence, increasing the weight of, vehicle or car will actually will deteriorate uh, the the gasoline, the mileage, the fuel consumption, for example. Okay, so those are, so it's trying to do some conflict resolution so that you don't want to um, compromise on certain requirements. So this becomes an information correlation matrix. Then you want to relate customer and design attributes. So you, the middle box. So normally we give some relationship. If there is no relationship, weak one or moderate one, so we give a symbol there, and there are some points or some numbers that we actually give really for different level of relationship, so that you will know which one that we need to focus on. Okay, so lack of strong relationship between customer attribute and design attribute shows that attribute is not adequately addressed, or the final product will have difficulty in meeting the customer's need. And if, same thing, if design attribute does not affect any customer attribute, then it may be redundant because it's not, going to improve or not going to increase customers' level requirements. Okay, customer, you don't need that attribute. So this is what I'm talking about. I mean, we try to establish the relationship between the need and the how. And this is the pretty strong, give a score of 9, medium 3, weak 1. Of course, there are other conventions, different numbers, different system developed by different people. But anyway, this is the fundamental. 1 times 3, 3 times 3. 3, medium is 3 times as stronger, or compared to weak, and strongest is a 9 and 9 scoring. Okay, I will show you the example after this. I mean, I will go through one example. Okay, I'm going to just go to these are theories. These are theories, and probably you will have difficulty trying to relate. I'm going to go this a bit fast so that you can see. I will show you one example, and you can relate that. We can download any examples in the internet. It's available. It's a lot of them. So you add market evaluation and key selling points. So this is another step, so that you enable designers to seek opportunities for improvement, because you want to compare the needs that customer needs and the technical requirements that you are able to meet it now compared to the current performance of the. So it is actually this part here. Okay, so we want to know how much we are actually comparing with the, sorry, is here. Okay, I'm going to go back a little bit. Here, this is part, customer perceptions of the our level compared to the market or compared to competitors. Okay, since this is not a class, I cannot be asking whether you have any questions or not. Now, so this is the final, okay, this is the technical targets, okay, and then the directions, high, low, which is more is better. So that's why you put the arrow here. It's an arrow, if you notice here, there is an arrow going up, going down, or it's actually no need to change, for example. Then you select the design attribute to deploy to the remainder of the process. Okay, this means that you identify design attributes that have strong relationship to customer needs, that have poor competitive performance or strong selling points. Then you deploy it to the next level and to the next level. So there are calculations involved, the technical importance. You can actually see if it is the highest, then you actually going to focus on that requirements. Okay. Now, right. These are some common pitfalls of QFD. You cannot do QFD on everything. You want to do on a big, a systems level or product level, and you don't apply to every project. Or there are inadequate priorities that you set. You have to set priorities which are important. I mentioned QFD is a teamwork, so that's why you need participants or the team to be, say, people who are knowledgeable, who have ideas about the product, who can actually give innovative and creative solutions. Okay, too much that focus. Okay, QFD is a way of thinking. It shouldn't be, it's a tool. Any quality tools must be treated as it's something that will achieve our objective of quality improvement or quality excellence. If we are too tool oriented, you at the end of the day you will be wasting a lot of time trying to construct a beautiful chart, a nice chart, that is not going to be beneficial. For example, SP, statistical control charts that you plot on the production line. So this is also one tool that this is used a lot in companies. If you only plot to be shown to the manager, then it's useless. You plot the control chart to see whether the process is behaving in a statistically controlled manner, and you can predict the next condition or whether process is going out of control or in control. Okay, so QFD is thinking of the product's areas for improvement, areas that you can improve to beat the market or to be on par with the market. Okay. Now, also hurry up and get done. This is not something that you can do it in one day or 1 week. It is probably few hundred man hours, or depending on the project, depending on the size of the product, or the complexity of the product. Okay, and it's no point developing and constructing the QFD if you fail to actually integrate and implement it, or integrate with, for example, Taguchi robust engineering methods to determine the best combination of the parameters for the particular product. So you can use QFD to get the voice of customers. Then you decide the next step of doing the experiment. I showed you this on the first slide, first video. Okay, so I mentioned to you these are the customer needs, and of course this is the primary, and this is the secondary. Primary is power. This is secondary, high performance, balance system, rapid modular. And these are the technical requirements, maximum processes. And I said just now, you can do the relationship between technical requirements. Now let's pick up strong. There is no strong positive. There's a moderate negative. There's a lot of moderate negative. There's one strong negative, which is maximum processes, which is 24, will influence manufacturing costs. Oh, yes, of course. You know, you have a lot of processes, then you actually you're going to, this cost is 220,000. Okay, so this is the kind of you know, end result that you probably will achieve. Let me just before I show you, I'm going to share another screen, which is let me see. Let me go to the okay. I presume some of you probably want to do research. So this is my friend, Professor Abdurrahman Rahim. He did his PhD in UTM with Professor Sharif. And he actually applied QFD for pultrusion machine design planning. And you can check this online, this paper. Application of QFD for pultrusion machine design planning. Okay. And truly enough, you know, if you go to the step, in fact, there are softwares for QFD. You can, you know, we can contact Dr. Rahman also for. So you have the pultrusion process, and then you have this what we call QFD stages, 4 stages, as I mentioned in my slides, Hauser and closing. This is the four houses of quality for QFD. And he actually developed this QFD, and I just show you here, the house of quality, through customer interviews and through analysis of the extant literature. In the literature, you can also collect some of the requirements. And if you are doing a PhD, obviously you want to go for, okay, so just share with you. Now I'd like to share, you know, so this is the house quality for management requirement in terms of this pultrusion machine. We can see here low cost maintenance, low poor. This is the customer requirement. This is technical requirements. Okay, and it is a logical, clear, step by step. It takes time, but you know, at the end of the day, you'll be able to understand your product better. You'll be understanding your even management requirement better. Okay, it is your creativity to develop, you know, different kinds of QFDs. So this is how quality for operators requirements. Okay, and for maintenance requirements, right? So these are, no, it is very powerful. It's very powerful, and it's not really very difficult. It sounds difficult. Okay, it sounds difficult, but it is not difficult. So you can you know you can look at different. Let me see. Okay. Right. I think you know, you get the idea. You get the idea of how to construct QFD. I've always emphasized that it's not about the mechanics of, you know, developing you know, a beautiful house of quality of QFD, or for that matter for any other tools. But the most important thing is how to think quality, how to build quality. For example, in this case, this is a tool for building quality in design stage. So there are tools for quality, manufacturing quality. There are quality tools for end of product, you know, inspection, testing, and so on. So some of the tools for, you know, during design stage, you know, you do reliability testing, you do Taguchi methods, you do even design for Six Sigma. Is you know, these tools are also being employed for design for Six Sigma, right? And I will share with you in other videos tools relating to statistics, statistical techniques for quality improvement. You know, the basic 7 tools, use SPC, statistical process control, and so many other things that is available in the internet. I'm just trying to supplement whatever is available in the internet and try to motivate all of you uh, to use tools and also to think about the best way of increasing and improving quality products, services, and at the end of the day, quality of life that we benefit from our improvement activities, inshallah. So with that, thank you for watching. I hope you will subscribe to my channel. Inshallah, I will try my best to produce more videos with better presentation and other things that I will pick up, inshallah. Thank you very much. I'll see you next time. Assalamualaikum warahmatullahi taala wabarakatuh.